My dear students, welcome to Amines part 5th. In this video, we shall study about chemical properties of amines. Let's begin with electrophilic aromatic substitution reaction. In this, students, we are studying about resonating structure of aniline. Aniline molecule, as you know, it is having primary amine functional group. So the nitrogen is having a lone pair of electron. It would be given towards the benzene ring to form carbon-nitrogen double bond. Nitrogen atom gets the positive charge with the delocalization of the pi electron towards the adjacent carbon atom. So the subsequent delocalization of pi electrons results in second, third and fourth structure. In the last structure, carbon-nitrogen double bond is reduced to single bond with a lone pair of electron on the nitrogen atom. And in structure second, third and fourth, ortho position, para position, and in fourth again the ortho position are rich with electron density. Thus, nitro group is ortho and para directing and a powerful activating group. Let's consider bromination reaction as an example for electrophilic aromatic substitution reaction. Aniline reacts with bromine water at room temperature to give white precipitate of 2,4,6 tribromo-aniline. Let's consider reaction. When aniline is reacted with bromine in water, the formation of 2,4,6-tribromo-aniline occurs along with hydrogen bromide. The name is given as 2,4,6-tribromo-aniline because with respect to amine functional group, first bromine atom is placed at second position, next at fourth position and the third one at sixth position. Thus the name is 2,4,6-tribromo-aniline. Consider the preparation of monobromo aniline. In this case, students, substitution reaction is carried out followed by hydrolysis of the substituted amines to get the required product. If we have to prepare mono-substituted aniline derivative, we have to protect the primary amine, that is NH2 group, by acetylation with acetic anhydride. Let us consider reaction when aniline is reacted with acetic anhydride in the presence of pyridine. Formation of acetanilide occurs. In this reaction, we are protecting amine functional group, that is NH2, by using acetic anhydride to form the compound as acetanilide. So as discussed earlier, when protection of the acetanilide group has occurred, next step we can proceed with bromination in acetic acid. So the removal of hydrogen bromide occurs, thus forming para-bromo-acetanilide, followed by hydrolysis results in para-bromo-aniline with acetic acid. Reason for formation of monobromo substituted product in the above reaction. The lone pair of electron on nitrogen atom of acetanilide molecule interacts with oxygen atom because of resonance. In the structure, students, nitrogen is having lone pair of electron which can be given towards the carbonyl carbon to form double bond. Simultaneously, the delocalization of pi electrons on the oxygen atom results to form the second structure. Nitrogen atom gets the positive charge whereas oxygen atom gets the negative charge. Hence, the lone pair of electron on nitrogen is less available for donation towards the benzene ring by resonance. Therefore, activating effect of NHCOCH3 group is less than that of amino group, that is NH2 group. Now students, let us discuss one more type of electrophilic aromatic substitution reaction, and that is nitration reaction. In strong acidic medium, aniline is protonated to anilinium ion, which is meta-directing. So, besides ortho and para derivatives, significant amount of meta derivatives are also formed. Let us consider reaction of aniline with nitrating mixture, which is a combination of concentrated nitric acid and concentrated sulfuric acid at a temperature of 288 Kelvin to give 51% of para-nitroaniline, 2% of ortho-nitroaniline, and 47% of meta-nitroaniline. Now let us consider preparation of para-nitroaniline. If we have to prepare para-nitroaniline derivative, we have to protect amine group, that is NH2 group, by acetylation with acetic anhydride. Let us consider reaction when aniline molecule is treated with acetic anhydride in the presence of base such as pyridine. Formation of acetanilide occurs. Once the preparation of acetanilide occurs, then substitution reaction is carried out, followed by hydrolysis of the substituted amide to get the required. Let us consider reaction. First step has been explained to you, in which primary amine NH2 functional group is protected by the acetylation by using acetic anhydride to form NHCOCH3. So further substitution reaction is carried out by reacting it with nitrating mixture at temperature of about 288 Kelvin to form para-nitroacetanilide. Para-nitroacetanilide is further hydrolyzed to form para-nitroaniline with acetic acid. Now let us consider sulphonation of aniline. In this, students, aniline reacts with concentrated sulfuric acid to form anilinium hydrogen sulfate. When aniline molecule is reacted with concentrated H2SO4, it forms anilinium hydrogen sulfate. Anilinium hydrogen sulfate on heating with sulfuric acid at 453 to 473 Kelvin produces para-aminobenzene sulfonic acid, which is commonly known as sulfonamic acid. Consider reaction. Consider reaction when aniline molecule is treated with concentrated sulfuric acid to form anilinium hydrogen sulfate salt. When this salt is maintained at a temperature of 453 to 473 Kelvin, sulfonamic acid would be formed. Sulfonamic acid can exist in dipolar ion, which is known as Zwitter ion. If we consider the structure of sulfonamic acid, students, this molecule is having both the functional groups. The first functional group, which is amine, that is primary amine, which is basic in nature, whereas the second functional group, that is sulfonic acid functional group, which is acidic in nature. Thus, this would be resulting in the formation of a Zwitter ion. It is also having the dipolar ion. The one end is the positive, whereas the second one is the negative, thus called as Zwitter ion. Consider Fiedel-Crafts reaction. Aniline does not undergo Fiedel-Crafts reaction, and the reason behind this is aniline forms a salt with aluminium chloride, the Lewis acid, which is used as a catalyst in the Fiedel-Crafts reaction. Due to this, nitrogen of aniline acquires a positive charge and acts as a strong deactivating group. Diazonium salts. Diazonium salts have the general formula Rn2 plus X minus, where R is an alkyl or aryl group. X minus is an anion which may be chloride, bromide, sulfite, boron, tetrafluoride, etc. The N2 plus is called diazonium group. Naming of diazonium salts. Let's study about naming of diazonium salts. Diazonium salts are named by suffixing diazonium to the name of the parent hydrocarbon from which they are formed, followed by the name of the anion such as chloride, hydrogen, sulfate, etc. For example, students, C6H5N2 plus Cl minus. In this case, first we write the name of C6H5, that is benzene, followed by N2 plus, it is called as diazonium, and third one is Cl minus, called as chloride. So the name is benzene diazonium chloride. Similarly, consider the next example, C6H5N2 plus HSO4 minus. So the first part in this case is C6H5. So the name has to be given benzene, followed by N2 plus, thus written as diazonium, and the next one is HSO4 minus, called as hydrogen sulfate. Thus the name of the compound is benzene diazonium hydrogen sulfate. Now the third example, C6H5N2 plus BF4 minus. So again the first part is benzene, next is diazonium, and the third one is tetrafluoroborate. Now let's discuss about stability of diazonium salts. Primary aliphatic amines form highly unstable alkyl diazonium salts, whereas aromatic primary amines form arene diazonium salts which are stable at very low temperatures, that is between 273 to 278 Kelvin, which is 0 to 5 degree Celsius. The stability of benzene disonium ion can be explained on the basis of resonance. Resonance structure of benzene disonium ion. Pi electrons from the benzene ring would be given towards the carbon nitrogen atom to form double bond. Simultaneously, delocalization of the pi electrons between the nitrogen atom occurs to form the second resonating structure. Again, the delocalization of the pi electrons inside the benzene ring occurs so as to reduce the positive charge at the ortho position, gives third resonating structure with positive charge at the para position, and again the pi electrons are delocalized to reduce the positive charge at the para position to form fourth resonating structure with a positive charge at the ortho position. Resonating structures shows that positive charge is formed at ortho and para position in benzene disonium ion. Now let us study about preparation of disonium salts, that is diazotization reaction. Benzene disonium chloride is prepared by the reaction of aniline with nitrous acid at a temperature of about 273 to 278 Kelvin. Nitrous acid is produced by the reaction of sodium nitrite, that is NaNO2, with hydrochloric acid. Let us observe the reaction. When aniline molecule is treated with sodium nitrite in presence of concentrated hydrochloric acid at a temperature of 273 to 278 Kelvin, formation of benzene disonium chloride occurs as C6H5N2 plus Cl minus along with sodium chloride and water. The conversion of primary aromatic amines into disonium salts is known as diazotization reaction. Due to its instability, the disonium salt is not generally stored and is used immediately after its preparation. Thank you, students. Rest of the part we can continue in next video.